Hello, my dear mechanical champions. How are you all? What's up? कैसे हैं सब लोग? Please guys do join me fast so that we can start this wonderful numerical practice session for the ISRO 2023 at the earliest. सबसे पहले ये बताइए, am I audible and visible to everyone? Please do write in the comment section. Hello Pagle son, welcome, good morning. Please do join me fast guys. And those who are already here, respond through the comment section if my audio and visual quality are fine. So the subject we will be discussing the question for is the fluid mechanics. Yes, hi Pawan, good morning, namaskar. Adab, Suprabhat, good morning, Sat Sri Akal, Assalam Walaikum, Wanakam. Please get yourself settled down fast so that we can start this wonderful session for ISRO. As you all know, every youngster is now aiming for joining the ISRO organization because of साहिल. ऐसा किसी ने, अच्छा आपने सिविल का वो देखा होगा, राइट? सिविल का एक सेशन देखा होगा वेयर रिचा मैम हैड टॉक्ड अबाउट हाईएस्ट पेइंग जॉब्स प्रोफाइल इन सिविल इंजीनियरिंग. सो द PSUs or government organization are having their organized salary structure, but if you join the private sector like oil companies, Gulf countries, then you will be having the better chances of getting the best possible salary in your career. All right? Definitely Sahil banayenge, but actually we cannot compare because there are two types of job profile one can aspire for: government sector or PSUs as well as the private sector. Both are having their advantages and disadvantages. Some of the students believe in the job security, established life, and some prefer to earn more. So it depends on person to person. But yes, if you are joining a private organization, then in-hand salary will be comparatively higher. But if you join a PSU or any other government sector, then in-hand salary might be less, but perks and allowance will be quite good. All right. So shall we start? Fluid mechanics is the subject we will be dealing with in today's session. Those who are attending my session for the very first time, this is my quick introduction. I am having more than 10 years of teaching experience. Yes, Deepak. That is due to gravity. Oh, in open channel, the flow is governed by gravity or potential energy. The flow will take place in the direction of potential energy because there is no change in pressure energy. Pressure in an open channel or river pressure remains constant. So the pressure does not decide the flow direction. It is the potential energy which decides the direction of the flow, right? High potential energy to low potential energy. And the velocity is governed by the gravity. So there is a conversion of potential energy into kinetic energy. That is how flow takes place in case of a river. I am mechanical engineering graduate from IIT Delhi, having also cleared engineering services examination, worked in Steel Authority of India Limited. These are my favorite subjects of mechanical engineering. If you have any doubt, anything to discuss in any of the subjects, you can always connect with me through the mail ID, or you can join me on the conventional question की बात कर रहे हैं क्या? पगले सन, you want conventional type of question? अब एग्जाम होने वाला ही है पवन, because now ISRO is quite free. So they will focus on conducting the examination. So in October, November, there is a chance that exam might happen. Right? So keep your preparation up to the mark, up to the level, so that you can be part of this prestigious organization which is doing very good and which is making the India proud. So keep your preparation. This is a golden opportunity for all the mechanical engineers specifically, because the vacancies are quite high for mechanical engineers. So this is my Telegram to you can join me on the Telegram also. The link is already there on the bottom of the screen. Thank you, Deepak. Thank you very much. Your positive words always makes my day, always bring the smile on my face. So thank you for bringing the smile. Thank you for motivating us to bring the concept in the more simple and easy and interesting manner. So you can join me on the Telegram by scanning this QR code also. If you are not part of my Telegram channel, there are already 1500 students who are part of the Telegram channel. Once you join me on the Telegram, I will share the PDF of this session as well. And everybody must be knowing that the UPSC ESE 2023 mains results had already been declared. Those who have qualified the mains examination, who are to appear for the interview, or if you know somebody who is going to appear for the interview, who has been called for the interview, then share this information that once you guys share your result with BYJU'S exam prep, then you will be getting the free interview guidance through our expert panel. So that will be the last stage, and based on your performance in the interview, you will be finally getting the rank, and accordingly you will be getting the department as per your choice of preference, right? Learning can't be done without errors. Yes. बैरोमीटर का barometer is different, manometer is different. So shall we start? Barometer is for measuring the atmospheric pressure, local atmospheric pressure, and manometer is used to measure the pressure at any point in the static fluid or static pressure in the flowing fluid. So if you are talking about the manometer or the pressure equation in general, that is a different thing. There is no as such equation for the barometer. Look how the barometer is designed. There is a mercury here and there is an inverted tube having the mercury. So the height of the mercury in the inverted tube will decide the atmospheric pressure here. So what is the barometric pressure or atmospheric pressure? So according to Pascal law, pressure here will be same as pressure here, right? So we can say here the pressure is PATM. We are traveling in upward direction minus, we are traveling in mercury, rho of mercury into G into H is equal to, here the pressure is vapor pressure. There will be vapor of the mercury. So we can write it as P vapor, right? So because the vapor pressure of mercury is very small, so the atmospheric pressure at this particular location, that is the local atmospheric pressure, is simply rho of mercury into G into H, rho GH. अच्छा, मैनोमीटर की इक्वेशन में ठीक है, देखते हैं अगर कोई क्वेश्चन अगर मैं लाया हूंगा तो. So let us start without wasting any time. There is a question on the screen. Everyone, please give it a try. The question is from the buoyancy and flotation. Everybody, आपको कैसे पता दीपक? Who told you? I was there in SAIL Durgapur. आप थे मेरे साथ? So the question is from buoyancy and flotation. A body of dimensions 1.5 meter by 1 meter by 2 meter, which is weighing 1962 Newton in water. When a body is kept in a liquid, so there will be a buoyant force exerted by the liquid, which is in upward direction. The weight of the body is acting in downward direction and the buoyant force is acting in upward direction. So apparent weight, we can say the apparent weight of the body. The apparent weight of the body is nothing but W actual minus buoyant force. Apparent weight is equal to W actual. What is the apparent weight? This is apparent weight. Actual weight minus buoyant force. What is the weight of the body in air? That is the actual weight. The question is to find out the actual weight. So we can say actual weight minus buoyant force by water is equal to apparent weight. And apparent weight in water is given as 1962 Newton. The question is to find out the actual weight. How to find out the actual weight? 1962 plus buoyant force by water. And buoyant force by water is 1962. According to Archimedes principle, we can find out the buoyant force by water. Density of water into G. Let me take as 10 because it is given as 9.81, but we can find out the nearest value plus volume of the body. It is not circular, it is a cuboid. So it is 1.5 into 1 into 2. So 1962 plus it will be 1.5 into 2, 3. So it is 30,000. It is almost 30,000, isn't it? So 30,000, so 31962. It is close to 31962 Newton. That is the actual weight. Weight in air is actual weight. Why? Because the density of air is very, very small. Because the density of air is very, very small, so the buoyant force by air is ignored. Buoyant force by air, because buoyant force is a function of density of the fluid. Buoyant force is a function of density of the fluid. So we could have said actual weight minus buoyant force by air is equal to apparent weight. But because the buoyant force by air is 0, so actual weight in air is the apparent weight in air is same as the actual weight. So the nearest option is the correct answer. It is slightly greater than 31962. It is slightly less than 31962. A is the correct answer. Yes, well done. Hindurav, Paglesan, Shreyas, good. Deepak, great. Let us move to the next one. If anybody is having any doubt, you can just let me know. A fluid of viscosity 0.7 Newton second per meter square. This is the dynamic viscosity. Why? Because the unit is Newton second per meter square. Or we could have called it as Pascal second. Or we could have called it kg per meter second. These are the unit of dynamic, absolute or coefficient of viscosity. And specific gravity is 1.3. Specific gravity is the ratio of density of the fluid to density of water. Flowing through a circular pipe of diameter 100 mm, the maximum shear stress at the pipe wall is given as tau naught is given as 196.2 Newton per meter square or Pascal. What is the pressure gradient of the flow? What do you understand by pressure gradient? dP by dx is called as pressure gradient. Pressure gradient. What is the unit of pressure gradient? Newton per meter square upon meter. Or we can call it as Newton per meter cube is the unit of pressure gradient. The gradient of any parameter is nothing but the change in parameter with the space. So pressure gradient is dP by dx. Can you find out dP by dx? If we start with tau naught is given by minus of dP by dx into capital R by 2. Capital R by 2. So dP by dx is equal to minus of 2 tau naught by R. or R can be taken as d by 2, or we can write it as minus 4 tau naught upon diameter. So this will give you dp by dx or pressure gradient. That is the slope of pressure variation. This is nothing but slope of P versus X curve, and X is the direction of flow. In the direction of flow, the pressure decreases. In the direction of the flow, as X increases, pressure decreases. So isn't it dP by dx negative? As X increases, the pressure decreases. So dP by dx will be negative. So positive value cannot be right. So if you put the values minus 4 into tau naught 196.2 upon diameter. What is the diameter? Do not commit the mistake in the unit. 100 mm, that is 0.1. So we can say minus 4 into 19.62. 19.62 is 2G. So multiplied by 4. So 20 into 4, something around 20, slightly less than 8,000. Isn't it? 20 into 4, slightly less than 8,000 Pascal, minus 8,000. It will be slightly less than minus 8,000. It cannot be greater than 8,000. So B is the right answer for the given question. How many of you have given the answer B without using the calculator? You are not supposed to use the calculator, guys. Let us move to the next one. I hope this is clear. This is very simple. This question is very, very simple. Which of the following is the correct assumption for the derivation of the Bernoulli equation? What are the assumptions for Bernoulli equation? Non-viscous flow. Bernoulli equation is valid for ideal flow. The Bernoulli equation is applicable only to the ideal flow. Non-viscous, steady, and incompressible. Plus, we can say there is no heat and work transfer. There should not be any other form of energy transfer, and it must be applied along the streamline. These are the various assumptions. So non-viscous fluid means viscosity is 0. Compressible fluid, we do not apply the Bernoulli equation. What equation we apply for the compressible flow? Anybody? Anybody can let me know what is the name of the equation we apply for the compressible flow? The name of the energy equation. Bernoulli equation is nothing but energy equation, but for the ideal flow. That is the energy equation for the ideal flow, which is non-viscous, incompressible, steady. Unsteady is incorrect. Rotational. When it is non-viscous, it is irrotational, because tau is equal to 0. There is no relative motion. So for the compressible flow, we apply steady flow energy equation, isn't it? Steady flow energy equation. First law of thermodynamics. We use first law of thermodynamics. Continuity equation, the mass conservation is Shreyas. Continuity equation is the mass conservation. I am talking about energy conservation. That is the first law of thermodynamics. Compressible fluids are analyzed by using the ideal gas equation or the concept of thermodynamics. So for energy conservation, we use the first law of thermodynamics. For a steady flow, just hold on. Is this clear? Can you guys hear me? Hello. All right. So let us move to the next question quickly. Yes, well done. अगर steady flow है तो steady flow energy equation. There is another equation for unsteady flow also. I hope you guys are clear with that. Water flows through, the next question says, water flows through a pipe of 200 mm in diameter. That is the diameter of the pipe, and 60 meter long, with a velocity of 2.5 meter per second. This is the average velocity. If nothing is mentioned regarding the velocity, we will assume it to be the average velocity. कई लोगों को, स्टूडेंट्स को कंफ्यूजन रहता है कि whether it is the average velocity or the maximum velocity. When nothing is mentioned about the velocity, then we will assume it to be the average velocity only. What is the head loss due to friction? Using Darcy's formula, assume F is equal to 0.005. If the value of F is very small, it is the friction coefficient. The value of friction coefficient is around 0.005, and the value of friction factor, there is the catch. The value of friction factor, that is 4 times of friction coefficient, that is around 0.02. The value of friction coefficient is around 0.005 and the value of friction factor is around 0.02. So we need to find out the value of frictional head loss according to the Darcy-Weisbach equation. So according to Darcy-Weisbach equation, do you know when do we use Darcy-Weisbach equation? Darcy-Weisbach equation is applicable to steady and uniform flow. The flow must be steady and uniform. Is it valid for laminar or turbulent? Darcy-Weisbach equation. Can you guys let me know whether the Darcy-Weisbach equation is valid for laminar or turbulent? It is given by FL V square upon 2GD. Is it valid for laminar or turbulent? Here F is the friction factor. So if we put the values, नहीं, यहीं पे गलती कर रहे हैं. This equation is valid for laminar as well as turbulent, both flow. Darcy-Weisbach equation is valid for laminar flow as well as turbulent flow, right? The only condition for the flow is the flow must be steady and uniform. What does that mean? There is neither the local acceleration nor the convective acceleration, both flow. And the condition for applying the Darcy-Weisbach equation is flow must be steady, it means local acceleration will be 0. Flow must be uniform, it means convective acceleration must also be 0. All right, that is the only condition. So HL is given by, it is friction factor. So can we write 4 into 0.005 into length is 60 meter into V square, that is 2.5 square upon 2 into 9.81. Let me take as 10 into diameter is 200 mm 0.2. Can you get me the answer? Can you guys get me the answer? So 10 into 0.2, it will become 4. This will get cancelled out with this. So it is around 0.005 into 60 into 120, 25 into 25, 625. So 6.25. Isn't it? Isn't it? कितना आ रहा है? It will be, how much it will be? This 0 will get cancelled out with this 0. So 0.05 into 6. So 0.3 into 6.25, isn't it? 0.3 into 6.25. How much is that? It is greater than 1.8. Is it 1.91 or 1.85? बताइए, will it be 1.85 or 1.91? Will it be 1.85 or 1.91? बताइए. It is looking close to 1.85 and 1.91. The options are very much close to each other. एक तो हमने यहां पे राउंड ऑफ किया है कि acceleration due to gravity we have taken as 10. It should have been 9.81. दूसरा, it is around this, right? 1.875. Because we have taken as 10, if it would have been 9.81, then the value would have been greater than 1.875. the value would have been greater than 1.875 because the acceleration due to gravity should have been taken as 9.81. That is how you should get your answer. So the correct answer is option D. It is not option C. Do you guys understand it? समझ में आ रहा है आपको? Money, why C is not correct, why D is correct. I hope this is clear. If the question would have asked you, to find out the pressure drop, can you find out the pressure drop in this line? So HL could have been written as delta PL by rho G. So delta PL would have been rho 10 to the power 3 into 9.81 into 1.91. Isn't it? What is delta P? So the value would have been delta PL in Pascal could have been calculated easily, right? Whether it is laminar flow or turbulent flow, it does not matter. Let us move to the next one. Next question on your screen. The next question says a convergent mouthpiece is discharging water under a constant head of 5 meter. The available head is 5 meter. If the diameter of the mouthpiece is 75 mm, then what is the discharge? Q is given by area into velocity. Area can be written as pi by 4 d square into velocity can be written as root 2 gh. Because the available head is 5 meter and the pressure is P atm. So all the available head will convert into kinetic energy. So H can be taken as V square by 2G according to energy equation. All the available head will convert into kinetic energy head. So V is equal to under root 2GS. That is how we get. So you need to put the value. The options are in liter per second. And 1 meter cube is equal to 1000 liter. So if we want to convert it into liter, then Q is equal to 3.14 by 4 into d square. So 0.075 square, or we could have written 75 square into 75 into 10 to the power minus 3 square. Can you get me the answer? Into under root of 2 into 10 into 5. So it will be around 10. So it will be around 10 into 10 to the power 3. So 3.14 by 4 into 75 into 75 into 10 into 10 to the power minus 6. So 10 to the power minus 3 liter per second. This will be the answer. Can you do the calculation? Can you find out the answer? Liter per second. This would have been meter cube per second. So 1 meter cube is equal to 1000 liter. Bataiye everyone, please give it a try without using the calculator. Calculation part you are supposed to improve or do it. ये 10 टू द पावर माइनस 2 हो जाएगा और 10 टू द पावर माइनस 2 हो जाएगा तो ये करीब आएगा Q इज इक्वल टू 3.14 बाई 4 इंटू 7.5 इंटू 7.5. Isn't it? So it will be somewhere around 2. So 14 into 3. 14 into, it is around 14 into 3.14 liter per second. So it is close to 43. 43.8. 43.8. Isn't it? 43.8 will be the answer. It is close to 44. In between 43 and 44. It is in between 43 and 44. The next one. Air flows through a duct and the pitot-static tube. Pitot-static tube is used to measure the velocity of the flow. Measuring the velocity, it is used to measure the velocity, is attached to a differential manometer containing water. The manometric fluid is water. The deflection of the manometer is 100 mm. That is the manometric fluid deflection. Assuming the density of air, the fluid is air. It is used to measure the velocity of the gases normally. The fluid is air, the density of air is constant, and which is equal to, it can be treated as incompressible fluid, that is why it is mentioned as constant, and the coefficient of the tube is 0.98. What is the velocity of the air considering the acceleration due to gravity as 9.81? So the question is to find out velocity. Velocity is equal to CV under root of 2gx into sm by sf minus 1. That is the formula. CV is 0.98 under root of 2 into, let me take as 10. X is manometric fluid deflection is 100 mm, that is 0.1. And manometric fluid is having the density as 1000 upon 1.22 minus 1. So because air, density of air is very, very small compared to density of water. Density of gases are very, very small compared to the density of water. So it can be taken as around 1000 only. Isn't it? 1000 upon 1.22 minus 1. So 1000 minus 1. That is 999 something. Or we could have taken as 10 only. So 10 into 10. So how much it will be? 1000 only. So it would have been around 0.98 into 2 into 10 or 10 into 0.1 is into 1000 something. Into 1000. So 2000. So we can write it as around, can we write it as around 0.98 into 10 into root 20? And root 20 is lying between 4 and 5. It is around 4.5. So 0.98 into 10 into 4.5 something. That will give you the answer. So 4.5 into 10 is 45. 45 into 0.98. It is less than 45, less than 450. Sorry, less than 45. It is less than 45. It is close to 45 but slightly less than 45, isn't it? What is the answer? It is less than 45. Option C. Isn't it? The answer will be option C. The challenge here is you are not supposed to use the calculator. So without using the calculator, even if you do not do the exact calculation, you can reach to the nearest option. The next question on your screen. Let us have a look to the next one. Water flows in a circular pipe. The shape of the pipe is circular. At one section, the diameter is 0.3 meter. Let me call it as D1. The static pressure, that is P1. Gauge 260 kilopascal. The velocity is 3 meter per second, that is V1. And the elevation, that is Z1, is equal to 10 meter above the ground level. The elevation at section downstream is 0 meter, that is Z2. And the pipe diameter V2, 0.15. Frictional effect may be neglected. Assume the density of water is 999. It is close to 1000. What is the gauge pressure at the downstream section? We need to find out P2 gauge when the acceleration due to gravity is 9.81. So if we assume if we write the Bernoulli equation, Bernoulli equation in terms of pressure. So P1 plus rho g Z1 plus rho V1 square by 2 is equal to P2 plus rho g Z2 plus rho V2 square by 2. Isn't it? P plus rho g Z plus rho V square by 2 is equal to constant. That is the another expression of writing the Bernoulli equation. Z2 is equal to 0. So the question is to find out P2. So can we say P2 is equal to P1 plus rho g Z1 plus rho by 2 V1 square minus V2 square. What is V1? V1 is 3 meter per second. So V2 will be equal to d1 by d2 whole square into V1. Isn't it? If V1 is 3 meter per second, what is the value of V2? The diameter ratio is d1 by d2 is 2. d1 by d2 is 2. So V2 is equal to 4V1. That is our continuity equation. So V2 is equal to 12 meter per second. So if we put the value, P1 is given as 260 kilopascal. Let me use in kilopascal only. P1 is 260 kilopascal plus can you guys solve it? Rho can be taken as 1010 into Z1. What is Z1? Z1 is equal to 10 meter. So we can write it as 10 into 10, 20 plus 1 by 2 V1 square 3 square minus 12 square. So it is something around this. So it will be 260 plus 20 minus, it will be minus 144 minus 9. How much is 144 minus 9? (144 minus 9) 135 by 2, isn't it? So how much is 135 by 2? So 280 minus something, or what you could have said 280 minus 67.5. So it will be around 213. It will be around 213, isn't it? How much is that? Did I commit any mistake somewhere? Will it be more than P1 or less than P1? Will it be more than P1 or less than P1? 260 kilopascal plus rho g Z1, P1 plus rho g Z1 plus or plus rho V1 square minus rho V1 square by 2, 12 square, 130. So why we are not getting 290 then? 80 cannot be correct. The static pressure is P1, velocity, this, and it will not be 20 na. Here I have committed the mistake. It is not 20. It is 100. Isn't it 100? Isn't it 100? 360 plus 100 is 260 plus 100. It will be 360 minus 67. So it is now it is close to 290 kilopascal. Isn't it? It is close to 290. Yes, it will be 100. So 290 kilopascal will be something around 290 kilopascal will be the answer. Something around 290 kilopascal. I hope you understood the concept, and I hope you understood how to do the calculation without using the calculator to get the nearest correct answer. Isn't it? So 260 minus 70, something around 260 minus 70, 360 minus 70, 290. So if you want the proper guidance for your examination, if you are sincerely preparing for your examination, do join our paid courses, because in our paid courses we complete the syllabus in an organized manner, giving you the PDF or the study notes along with the numerical practice sessions are also there. We provide you the study material and question bank as well. So all the help support is provided to you if you join us our paid courses. Vision Gate 2024 is running, and we have recently started a crash course. Are you guys aware about the crash course? If you could not join our long-term batches, then you can join our Vision crash course for 2024. And today there will be a first class for the fluid mechanics for this crash course. You can always contact the mentioned number, or you can download our BYJU'S exam prep app and register for the counseling session. Enroll yourself for the counseling session. They will guide you with the complete process and anything else which you want for deciding whether to join or not. All right. The next question is very, very simple. Next one. What is the viscosity of the liquid whose kinematic viscosity is 6 stock? So we can say kinematic viscosity is 6 into 10 to the power minus 4 meter square per second. And the specific gravity is 1.90. So what is the density? 1900, isn't it? 1900. 1.9 into 1000. So we need to find out the viscosity, means dynamic viscosity. Density into kinematic viscosity. So density is 1900 into 6 into 10 to the power minus 4. So it is 0.19 into 6 Pascal second, Newton second per meter square, that is Pascal second. So 1.19, or we can say it is around 0.2 into 6. How much is that? 1.2 Pascal second. In Pascal second it is 1.2. In Pascal second it is 1.2. And in poise it is around 12. In poise it is around 12. अक्टूबर में होने के चांसेस हैं. अपडेट अक्टूबर, सितंबर एंड या अक्टूबर में हो सकता है. कोई लॉजिक नहीं है उसके पीछे. द ओनली थिंग इज बिकॉज नाउ द इसरो इज फ्री फ्रॉम Chandrayaan 3 launch, and now they can have the examination at the earliest. So in October, September, there is a chances. So the answer to this question is $11.40. The next one is beautiful question. The next question on your screen. A 2 meter wide tank, width is 2 meter, contains water up to a height of 0.5 meter above its base, an immiscible liquid of specific gravity 0.8. It means there are multiple fluids, and so many students are confused how to analyze the multiple fluids. Is filled on the top of the water up to a 1 meter height. What is the total pressure on one side, pressure force on one side of the tank? Density of water is taken as 1000 and acceleration due to gravity is 9.81. So how to analyze if there is a vertical plane surface of 2 meter height, the water is up to a height of 0.5, there is a water, and there is some liquid up to a height of 1 meter. This height is 1 meter and this height is 0.5 meter. This is the free surface. So the simplest way to write the pressure force is average pressure into area. There are two surfaces, or we can say it can be divided into two parts, 1 and 2. So P1, PG1, PG is the average pressure. The pressure which is acting at the centroid is called as average pressure, which is constant, plus average pressure at G2 into A2. So G1, if we want G1, G1 is somewhere here, G1, and G2 is the centroid of the second surface, like this. This is G2. So what is PG1? Can you find out PG1? PG1 is equal to density of liquid 0.8 if we want in kilonewton. The options are in kilonewton. You can check first the option. So if you want the answer in kilonewton, that is why we will take the specific gravity rather than density. Rho into G into x bar, x1 bar. What is the depth of centroid G1? Height is 1 meter, so it is 0.5. Then A1, what is A1? This is 2 meter, 2 into 1. This is PG1 into A1. Are you getting it? What is PG2? What is the pressure here? We will say rho G into 1. So 0.8 into 1 meter plus 1 into, this is 0.5 by 2. Multiplied by, this is the pressure PG2. This is the pressure into area 2 into 0.5, and then multiplied by 10 multiplied by G. This will give you kilonewton. I hope you understand. What I wrote is PG1 is equal to rho 1 G into x1 by 2. Let me call it as x1. And what is PG2? That is rho 1 into G into x1 plus rho 2 into G into x2 by 2. That is PG2. This is, let us say, x2. And A1 is equal to x1 into B. B is the width. And A2 will be equal to x2 into B. That is what we have used. So if you simplify this, 0.5 into 2 is 1. So it will be 0.8 plus, then it will be 2 into 0.5 is, 2 into 0.5 is again 1. Then it will be 0.8 plus 0.5 by 2, 0.25. Then multiplied by 10 kilonewton. So 0.8 plus 0.8, 1.6, 1.685 into 10 kilonewton. So it is around 18.5 kilonewton. Are you getting around 18.5 kilonewton? Are you guys getting around 18.5 kilonewton? Do you understand this or not? Do you guys understand this concept or not? The answer will be very much close to 18.5 kilonewton. When there are multiple fluids, you can easily solve taking the average pressure at the centroid G1 and taking the average pressure at centroid G2. I hope you guys understood this. Yes or no? Is this clear to everyone? The next question from the boundary layer theory. Air at a standard condition flow over a flat plate. The free stream velocity is 3 meters per second. What is the thickness of the boundary layer at a distance 1 meter from the leading edge of the plate? Take the kinematic viscosity of air, 1.5 into 10 to the power minus 5. What is the unit? Meter square per second. And the density is given by 1.23. So we need to find out the, first of all, we need to find out the Reynolds number, whether the boundary layer is laminar or turbulent at x is equal to 1 meter. So it will be rho into u infinity or u infinity x by kinematic viscosity. U infinity into x by kinematic viscosity. U infinity is 3, x is 1 meter upon kinematic viscosity 1.5 into 10 to the power minus 5. So it will be 2 into 10 to the power 5, which is less than 5 into 10 to the power 5. So it is Laminar boundary layer. The boundary layer will be laminar. When the value of Reynolds number becomes less than 5 into 10 to the power 5, then the boundary layer will be laminar. So delta x is equal to 4.64 x upon under root of Rex. Can you do the calculation? 4.64 into 1 upon under root of 2 into 10 to the power 5. How much is that? So 4.64 divided by 10 to the power 4, it means 100 into root 20. Root 20 is almost 4.5. It is greater than 4, less than 5. So it is around 4.64 upon 100 into 4.5 meter. If we want to find out in centimeter, then into 100. So it will be somewhere around, it is somewhere around greater than 1 centimeter. It is slightly greater than 1 centimeter, isn't it? But is it B or D? Oh my goodness. 1.8 mm is not true. 1.8 mm is not correct. 10.3 centimeter is not correct. What about B or D? Which of them is correct? Which one of them is the correct answer? Is it B or D? बताइए. It should be slightly greater than 1. 10.3 mm is 1.03 centimeter. 10.3 millimeter is 1.03 centimeter, isn't it? So the more appropriate value is 1.03. Are you getting it? 1.8 centimeter is not close to 1 centimeter. It is 1.03 centimeter, which is more closer to 1 centimeter. नीरज 1.8 तो बहुत ज्यादा हो जाएगा. 1.8 will be very large. It should be very much close to 1 centimeter, slightly greater than 1 centimeter. So 1.03 is more appropriate. If you would have used the calculator. So कई बार ऐसा होता है, listen very carefully, you might have two options very much close to your answer. But in that case, you should always check where you have make the calculation round off. So accordingly, you should be very careful about selecting the right answer. I hope this is clear to everyone. I hope you learned from this. 1.8 is not close, 1.03 is more closer. The next question. The water is flowing with a velocity of 1.5 meter per second. In a pipe, this is the average velocity. In a pipe of length 2500, diameter 500, millimeter, diameter is in millimeter. A valve is provided at the end of the pipe. There is a valve. What is the rise in pressure if the valve is closed in 25 seconds? Time taken to close the valve is 25 seconds. So we need to find out whether it is a gradual closure or the sudden closure. Velocity of the pressure wave or the velocity of the sound in the fluid is taken as 1460. The question is from the water hammer or unsteady flow. The question is from the unsteady flow. Acha. Oh, sorry, Pawan. I forgot. I was not aware that there is a ticker moving. Areva, hydrology is also there. It means you are from civil branch, hydrology. So, what is the critical time of closing the valve? 12/c. That is critical. That will be the deciding factor, critical time. So, if the actual time, this is the actual time, is less than critical time, then it is sudden closure. If the actual time is greater than critical time, then it is a gradual closure. And in case of sudden closure, we use the energy conservation, energy equation. In case of sudden sudden in case of sudden closure, in case of sudden closure, we use the energy equation, and in case of gradual closure, we use the momentum equation. So first of all, we need to check whether the time of closing the valve is gradual, is less than critical. What is critical time? 2 into L, L is 2500 by C, C is the velocity of the pressure wave, 1460. So it is close to, can we write it as 2 into 2500 upon 1500? So 10 by 3, something around 3.33 second. So it will be 3.33 second and actual time is 25 second. So actual time, we can say actual time is greater than critical time. So it is gradual closure. Because the valve closure is gradual, then what we can say is we can apply the momentum equation. This is the pipe, let us say. We are analyzing this length L. So here the velocity is V, and because it is a gradual closure, so velocity is decreasing from V to 0. The velocity is becoming 0 in this length L. So the force exerted, that is change in pressure delta P into area is equal to rate of change of linear momentum. So rate of change of linear momentum is mass flow rate into change in velocity, isn't it? So delta P into area is equal to what is mass flow rate? Density into discharge into V. And what is discharge? So we can say rho into volume per unit time. So A into L by T actual into V. Delta P into area getting cancelled out. So delta P is simply rho into L upon rho into L into V into T actual. So density is 1000, it is water, the fluid is water, and length is 2500 into velocity is given by 1.5 meter per second, and the actual time of closing is the valve is 25 seconds. So 25 into 2500, it will be 100. So it will be in Pascal, the answer will be, so we can say it is 1.5 or 150 into 10 to the power 3 Newton per meter square or Pascal. It is 150 into 10 to the power 3 Pascal or 150 kilopascal. The options are in Newton per centimeter square and one is in kilonewton per centimeter square. If you want to convert it in Newton per centimeter square, 1 meter is 10 to the power minus 2 centimeter. 1 meter is 100 centimeter. So 150 into 10 to the power 3 upon 10 to the power 4 Newton per centimeter square. So this will be 15 Newton per centimeter square. The answer will be 15 Newton per centimeter square, isn't it? Option A is the correct answer for this one. All right. So that is all from my side, guys. Let us stop here only. And please do practice some more questions. Let us discuss one last question. The stream function is given by this expression. One last question and then we will stop. The stream function is given by psi as a function of x and y. It is 2D flow. What is the resultant velocity at point x is equal to 2 and y is equal to 3? So the velocity in x direction is del psi by del y. What is del psi by del y? Minus 2y, isn't it? So it will be minus 2 into y is 3. So minus 6. What is v? Minus of del psi by del x. What is minus del psi by del x? Differentiate psi with respect to x. 4x minus 4x. So v is equal to minus 4 into x. X is 2. So minus 8. U is minus 6. V is minus 8. So velocity, the resultant velocity is under root of u square plus v square. Under root of minus 6 square plus minus 8 square. What is that? 36 plus 64. under root of 100, that is 10 meter per second. That is the resultant velocity. It will be 10 meter per second. Shreyas, क्या कर रहे हैं आप लोग? It will be 36 in plus 64. Option A. A will be the answer, right? A will be the correct answer. चलिए आज के लिए इतना ही. कुछ क्वेश्चंस मैं असाइनमेंट के लिए दे रहा हूं, ये आप लोग करिए. ब्यूटीफुल क्वेश्चन है. अगर इनमें किसी को कोई डाउट होगा, यू कैन लेट मी नो. दिस इज अगेन योर असाइनमेंट क्वेश्चन. And there will be an important workshop on 29th. Tomorrow there will be an important workshop taken by Sanjay Rathi sir. He will be discussing about the right strategy to utilize your next 5 months. The last couple of months or last few days are very, very crucial for clearing any examination with the best possible score. So do not forget to join this workshop. It is completely free. You just have to register yourself for the workshop. All right, you just have to register yourself, and the link to register yourself is already there in the description box. Let me give you a couple of more questions. This is again assignment. Now try to solve these questions and bring me the answer. And if you are not part of my Telegram channel yet, it is my humble request, guys, do join me on the Telegram. The link is already there on the screen. And the QR code is also on the screen. So that is all from my side, guys. I really enjoyed this session, discussing, sharing my understanding of fluid mechanics with you. I hope you guys have also enjoyed this. So thank you very much for joining in. Thank you very much for your active and positive participation. So see you in the next class. Till then, enjoy, take care, have a good day and a great career ahead. Thank you and Jai Hind.